Hi guys, today we are going to talk about cross products. So first, the definition is that if we have two vectors that are in 3 dimensions, we can find their cross product by taking the second term of the first vector times the third term of the second vector minus the third term of the first vector times the second term of the second vector, blah, 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 blah. Can you tell how gross that is? Okay, so there's going to be an easier way to keep track of all of these terms. First of all, there's this mess of stuff right here, and then we have an I, and then it's minus. It feels like it should be plus because we were just like this plus this plus this. Be careful. There's a minus sign there instead. So make sure, that's why I have it there in red, so that way we can remember he is frickin' minus. And then we have all of this junk to find the term for J, then we have a plus, and then all of this junk to solve for K. Now, there's an easier way to remember all of this. Basically, what we're going to do is we're going to make a matrix out of I, J, and K, and each of our vectors. So we're going to have I, J, and K across the top. So like these originally were I, J, and K, V1, V2, V3, W1, W2, W3. So then when we're trying to find out what our I term is, I'm going to circle that I and put a line through both the column and the row that I is in. Then we're going to find the determinant of that matrix. So just a sidebar, determinant of a matrix, we'll take A times D minus B times C. So we're going to multiply diagonally and subtract them. Okay. So if we were to find the determinant of this part, we would take V2 times W3 minus W2 times V3, or reverse those, however you want to say it. When we're looking for our J term, we'll circle J, cross out the rest of the row and column that J is in, and then we'll find the determinant of this leftover matrix. So we'll take V sub 1 times W sub 3 minus W sub 1 times V sub 3. When we're looking for that K term right here, we're going to cross out the row and the column that K is in, and then we'll find the determinant of that matrix. V1 times W sub 2 minus W sub 1 V sub 2. So that's where those terms up at the top are getting together. So for this, we're just going to go ahead and use this matrix method to find our cross product. So here's some stuff that's nice to know about cross products. U cross V and V cross U are not the same thing. They're actually going to be opposites of each other. So if you take U cross V and V cross U, you can multiply one of those by -1 and you'll get the other one. If we cross two vectors and get 0, cross the same vector with itself, we'll get 0. If we cross two things and they're 0, that means that those two vectors are parallel. All right. Another big thing, probably the biggest thing, is that the cross product is orthogonal to both of the vectors that we were given. So over here, we have this vector A and vector B. And you can see right here, this AB coming up outside of it, he's going to be perpendicular to A, and he's going to be perpendicular to B. So he's going to be able to be orthogonal to both of those vectors. That's the biggest part. Also, another use for cross products is that the sine of theta is going to be equal to the magnitude of the cross product divided by the magnitudes of those two vectors multiplied together. So we had cosine equals the dot product divided by the magnitudes multiplied together. Now we just have another formula to find the angle between two vectors. Okay, we want to find the cross product of V cross U. Okay, so first thing we're going to do, we got V cross W. Did I say U? I meant W. I'm sorry. So we are going to start with our vector, or our matrix, I, J, and K. V goes first, so remember he's 1, 2, 1. This guy is. And this guy is 3, 1, 2. Okay. Okay, so we got an I there. Remember, in front of the J, we need to subtract. So I always put that in red so that way I remember. And then we have that same matrix with a J on it, plus that same matrix with a K on it. Okay, I'm gonna make my marker kind of fat now. So in this first one, we want to find I. So we're gonna cross out the row and column that I is in. In our second guy, we want to find J. So we'll cross out the row and column that J is in. Then the last one, we want to find K. So we'll cross out the row and column that K is in. Okay, so now we have to find our determinants. So to find our determinants, whatever is going to go in front of our I here, we're going to take 2 times 2 minus 1 times 1. So 2 times 2 is 4, 1 times 1 is 1, 4 minus 1 is 3. So we got 3I there. Then there's that minus sign. And we'll do our determinant again to find our J term. So we have positive 1 times 2 minus 3 times 1. So we've got minus, let's see, 2 minus 3 is negative 1. So minus negative J, oh, that's kind of gross. Make that a plus 1J. Then we have a plus sign, and we'll find the determinant of this 2 by 2 matrix to find our K term. So we'll take 1 times 1 minus 3 times 2. So 1 times 1 is 1, minus 3 times 2 is 6. So 1 minus 6 is negative 5. So then we have minus 5. K there. So that's our cross product. Now, this assignment is on Canvas, so here's how I would like for you to input your answer. Instead of having it in I, J, and K, I went ahead and made a component form on Canvas for you. And there's a blank, and then another blank. So in our first blank, we'll put that 3. In the second blank, we'll put 1. And the third blank, we'll put negative 5. Okay, let's look at the next one. Still going to take V cross W. So we'll go ahead and make that matrix I, J, and K. V comes first, so that will be my next row. W comes second, so he'll be my next row. So there's our I, all right. Then we have minus our j term. There's j plus that. Okay, all right. So on this first guy, we're trying to find our I term, so we'll cross out the row and the column that I is in. In the second guy, we're trying to find j, so we'll cross out the row and the column that j is in. Oopsies. And then in our last term, we want to find k, so we'll cross out the row and column that k is in. Then we'll go ahead and start trying to find our determinants. So for this guy, we'll take 7 times 5 minus 3 times negative 2. So that means we got 35 minus negative 6, or 35 plus 6. That's 41. And then there's an I. Let's put my I there. All right. Then we have our minus sign. Careful about that. All right. So now to find our j term, let's find this determinant. So 3 times 5 minus negative 2 times negative 2. All right, so that means we've got 15 minus 4, and 15 minus 4 is 11. So we've got an 11j there. And we had a minus there before, so I need to still have that minus there now. Okay, then we want to find our k term. We'll find the determinant by taking 3 times 3 minus negative 2 times 4, negative 2 times 7. Sorry, I was already in my head trying to do the math. So let's see, we got 9 minus negative 14, or 9 plus 14. 9 plus 14 is 23. So then we'll have plus 23, okay. And like I mentioned earlier, that's the same thing as 41, negative 11, 23 for that Canvas assignment. All right. So now we want to find a unit vector that is orthogonal to both vectors. So for it to be orthogonal to both vectors, we want to find the cross product. That's our first step. And then since we want it to be a unit vector, after we find the cross product, we will just find the unit vector of the cross product. Okay. So let's take V cross W. If you take W cross V, that's totally fine. Just your vector is going to be in the opposite direction as mine. Even if they're in the opposite direction, they're still going to be orthogonal to both vectors. So there's nothing to worry about. You are still right. So we're going to find that cross product. We need our I, J, and K. I decided I was going to have V go first. So that's 3, negative 4, 1. And W will go second, so that's negative 3, oopsies, 6, and 0. All right. There's my I. Remember, we subtract our J. Plus that k. All right. So in this first one, we're trying to find I. So we'll cross out I's row and column. Here we're trying to find J, so we'll cross out J's row and column. Over here we're trying to find K, so we'll cross out K's row and column. All right. So let's find these determinants. So we'll take -4 times 0. So that's 0 minus 1 times 6 is 6. So we'll get -6i. Over for our j term, we'll take 3 times 0. That's 0 minus. And then -3 times 1 is -3. So plus 3. So that means I got a 3j right in here, but I still got that minus sign out front. So he's minus 3j. Then for k, we'll take 3 times 16 and get 18 minus -3 times -4 is 12. 18 minus 12 is 6. So then we'll have plus 6k. All right, so now that we got that cross product, so cross product, done. Now we have to find the unit vector of this cross product. So remember, to find the unit vector, we're just going to take this vector and divide it by his magnitude. So let's look at the magnitude of V cross W. So we'll take that -6 and square it, plus -3 and square it, plus 6 and square it. So we got 36 plus 9 plus 36. That'll be the square root of 81. I'm 99% sure. 36 plus 36 is 72. 72 plus 9 is 81 for sure. Cool. And then we know the square root of 81 is 9. So I'm going to name this guy U for unit vector. I'm going to take each term, like that -6, and put him over 9. That'll be I, minus 3 over 9j, plus 6 over 9k. I would love it if you wouldn't mind simplifying that. So -6 over 9 is -2/3 I, minus 3 over 9 is 1/3 j, plus 6 over 9 is 2/3 k. In Canvas, the way that I'll want you to put this, there will be a blank, or there will be a component form with 3 blanks. So the first one will say -2 over 3. The next one will say -1 over 3. The next one would say 2 over 3. That's how I would want it in Canvas. Okay, one last one. Okay, so remember, first we need to find the cross product. So we're going to have to take R cross T. If it helps to write this in component form, go for it. So R is going to be 2, 3, -2. With T, we got an I term, that's 5. We don't have a J term, so that means we have a 0 in the middle. And then we have minus K, so that's a -1 for my last term. Okay, so we got I, J, K. I decided that I wanted R to go first, so that's 2, 3, -2, and then 5, 0, -1. Hi. And then we have to make sure that we subtract our J. Plus our K. Okay, so that's not a good color to use. Let's use this. So we want to find I in this first term, so we'll cross out the row and column that I is in. We want to find J in the second guy, so we'll cross out the row and column that J is in. And then K, we'll cross out the row and the column. Okay. So now we'll go through and solve for our determinants. Oopsies, you're still fat. Didn't mean to keep you fat. There we go. So we have some junk I for that determinant. Well, remember there's a minus sign there. Some junk J plus our determinant. Okay, cool. All right, so we'll take 3 times -1 and get -3 minus 0 times -2 is 0. So we get -3 I to start off with. Then we'll take 2 times -1, that's -2 minus 5 times -2 is -10. So then we'll add those guys together. -2 plus 10 is 8. I still have that minus sign outside, so I have minus 8J. For K, we'll take that 2 times 0. That's 0 minus 5 times 3 is 15. So then we've got a minus 15K for that cross product. Okay, so now to find the unit vector of this, we need to find the magnitude of this vector. So we'll have to take 3 and square it, plus 8 and square it, plus 15 and square it. I did not think ahead. Grabbing a calculator, sorry. So we got 9 plus 64 plus 225. That's a square root of 298. I got excited for a second. I thought it was 289, and I was like, that comes out pretty. It does not. Just leave it as the square root of 289, or 298, I'm sorry. So when we write our unit vector, we're going to take this guy. I'm going to name him U for unit. I'm going to take my original, or my cross product and divide it by his magnitude. So we've got -3 over the square root of 298. I minus 8 over the square root of 298J minus 15 over the square root of 298K. And then just as a reminder how this will look on Canvas, you'll have 3 boxes inside of those brackets, and you'll just fill in each component form. So like this first guy will have -3 over square root 298. Just as a reminder, your square root is option V. Over here, you'll put negative 8 over square root 298. Over here, you'll have negative 15 over square root 298. All right, guys, I will see you guys later.